In this session, we will take a look at another analytic technique called logistic regression. Let's just briefly review the table of contents for the session. We will look at what a logistic regression is and we'll introduce the concepts of a logistic regression. We'll use a case study to illustrate the concepts. We will talk about S-curves and odds ratios. We will look at the model form, how you prepare data for a logistic regression, and what estimation techniques are used for a logistic. We will look at how you run a logistic regression in SAS using proc logistic procedure. Logistic is not something that you can run in Excel directly with the add-in. Obviously, we'll spend a lot of time understanding the output of the logistic and how we evaluate and validate a model. We'll take a look at different ways of validating the output and the performance of a logistic, including gain charts and scoring. So what exactly is a logistic regression? It's a form of a regression analysis, but it's used to predict discrete variables using a mix of continuous and discrete predictors. So essentially it is used when the research objective is focused on whether or not an event occurred, not when an event occurred. And it's also used for predicting the probability of occurrence. So this is something that we will spend a lot of time on to make sure we understand well. Instead of building a model for y directly, which is the response, the y variable, what you end up doing in a logistic model is that you build model for the log of the odds of y happening. So that is why it is called a logistic or a logit model. But essentially we don't directly build a model for the direct response variable y, we build a model for the log odds of the response. Now, as we said, logistic regression is used when your dependent variable is discrete or categorical. Your independent variables could be continuous or categorical, it doesn't matter. So what are some examples of when a logistic regression is used? So here's a couple of examples. Let's say you're modeling the default behavior in a credit card loan portfolio or a credit card portfolio. So has someone defaulted on their credit card payments or not? So the outcome, the default outcome, is really a categorical variable with yes or no values. Similarly, let's say that you're modeling response to a direct mail campaign. Is someone likely to respond to your direct mail campaign or no? So the outcome again in terms of response is really yes has responded or no has not responded. Or customer acquisition models, have you acquired the customer successfully or have you not been able to acquire the customer? Again, only sort of categorical discrete outcomes. Now the examples that we've seen so far are all binary outcomes, where there is only a yes, no or a 1-0 response. But a logistic is not restricted to only categorical responses that have binary outcomes. You can have logistic regressions for categorical variables with multiple responses. So supposing I'm looking at the likelihood of recommending a purchase on your website, for example, and maybe you run a survey and the options are strongly recommend, will recommend, neutral, will not recommend. Right, so the categorical response, but more than 2 options. So you can build a logistic regression for those instances as well. So just to identify the different types of logistic regressions, the binary logistic is what's widely used and in a variety of business situations, and that's what we are going to focus on in this class. Typically is used when your response variable has only a binary or a dichotomous outcome, and if you have more than 2 outcomes in your categorical response variable, you will use either an ordered logit or what is called a multinomial logit. An ordered logit is used when your response variable has more than 2 outcomes, but the outcomes are also you're able to order them in a meaningful way. There is some ordering of the outcomes. So for example, strongly agree, neutral, disagree, strongly disagree. So then there's some ordering of the outcomes. There are multiple outcomes and they can be ordered. A multinomial logit is essentially an ordered logit, or it's a logistic used when you have multiple responses but the outcomes have no ordering. So for example, supposing you're trying to build a model that predicts which location a customer might choose for travel for their annual vacation, and maybe you have 5 options and they can choose any one of those 5 options. There is no ordering in the option. The outcomes are discrete because there are only 5 options, but there is no ordering of the outcomes per se. That is a multinomial logit model. In this class, we are going to focus only on binary logic, and like I said earlier, it is widely used in business for multiple business situations. The logic of an ordered logic or a multinomial logic is similar to a binary logic. So once we understand a binary logic model, it's fairly easy to extend that logic to an ordered logic or a multinomial logic model. Let's use a simple case study to sort of understand the concepts of a logistic regression and to relate it to what we are learning in terms of concepts. Let's consider the case of a bank that has given out personal loans to a set of its customers. Now, the bank has already given the personal loans, and this is historical data. They know, let's say the personal loans were for a period of up to 1 year, and they know already which customers have repaid the loan in full and which customers have defaulted. So what they want to use that data now for is to figure out a predictive model that will decide loan eligibility for future customers. So essentially, based on historical data, they want to correlate the default behavior of customers with attributes of the customers so that they can predict for future customers which customers are likely to default, and therefore you're going to decide loan eligibility based on the likelihood of the default probability of the customer. So we'll take a very simple case to start with, and then we'll extend it. Let's say that the data that are available to you via the applications for the personal loan include income of the customers, the employment status of the customer, the credit score of the customer, and then based on your the bank data, you have default outcome, whether or not they repaid the money or didn't repay the money. So if you look at the types of variables, the income is a categorical variable. It is not a continuous variable in this data set. There are levels of income: low income, medium income, high level, high income, etc. Employment status is also a categorical variable, unemployed or employed. The credit score is a continuous variable in the sense that the score can be anywhere between 400 to 900, so it's a continuous variable. The default variable obviously is categorical because either the customer has defaulted or they have not defaulted, so it's a 0-1 variable. Now, just based on our understanding of regression techniques, the way, one very intuitive way to assess the impact of factors on eligibility of a personal loan is to set up a linear regression model. So you say that loan eligibility or default behavior is a function of income, employment status, credit score. And so if I build a linear model, I will essentially end up with a model that looks like this: loan eligibility Y, which is simply the inverse of the likelihood of default, right? So the higher the likelihood of default, the less eligible you are for a loan. So the eligibility is directly a function of default. So eligibility equals to beta 0 plus beta 1 into income plus beta 2 into employee status plus beta 3 into credit history plus the error term. This is familiar to us from the linear regression model, and so an intuitive way to sort of relate the default behavior to attributes is to set up a linear regression model like this. Now let's take a look at the data before we do anything else, and I'm going to start off with a simple logistic which has only one independent variable, let's say credit score. And just for the purposes of illustration, let's say I have a data set that has 1000 entries, and here's a small sample of the data. So I have a credit score variable, and then I have a default yes/no variable. 1 in that variable for default implies that the customer has defaulted on the loan payment. 0 implies the customer has not defaulted on the loan payment. So this is the data that I have. So if I were to go back to my regression equation with only one independent variable, I would say eligibility equals to beta 0 plus beta 1 times credit history plus the error term. The error term we will not need to estimate because we assume that it will average out to 0. So one of the first things that we would do, assuming we were doing a linear regression model, and I had one independent variable, one dependent, and you may remember this from the highway deaths example that we've used in the linear regression class, is to build a scatter plot to look at what is the relationship between credit history and eligibility, right? That's the first step that we would want to do. This is what the scatter plot looks like. I have the default yes/no on the y-axis, and I have a credit score on the x-axis, and this is what the scatter plot will look like. In fact, let's just take a look at developing the scatter plot. So this is my data. I have a customer ID number, I have a credit score variable, and I have a default yes/no variable. If I just simply wanted to build a scatter plot, this is what it would look like. I've simply taken credit score on my x-axis, default behavior on my y-axis, and if I take a look at the scatter plot, you can see because default behavior is only 0 or 1, right? On my y-axis, I will have data for default either on the 0 point or on the 1 point. There is no other values that are possible for default. So that's why you see that you have a scatter plot which really is restricting the points to the 0 level and the 1 level. Now, if you take a look at this, clearly you can see that you're going to have a little bit of a trouble with a linear model, right? This is not very useful. Is this very useful? Not really. Not very useful, right? What is a better way of looking at the relationship between default and credit score? Can we think of a better way of looking at eligibility and credit score instead of doing a simple scatter plot between credit score and default? Can we think of a better way that looks at the relationship? Because ultimately we do know that there is a relationship between default and credit score. How do we do that? So a better way may be to take a look at the credit score, divide that into buckets, and then take a look at the percentages of default versus not default by buckets of credit score. So essentially what I'm proposing is something like this. Take your credit score variable and divide it into different buckets. And once you have the buckets, you then look at what is the total number of default instances in my bucket and non-default instances in my bucket. So reject is essentially someone that you should have rejected for a personal loan because they have defaulted, and accept is people that have paid in full. So it's a good thing that you can accept someone with a credit history like this because they have repaid the loan in full. So this potentially could be one approach that we could take to look at a relationship between credit score and the default outcome.